Madam, kindly unmute yourself.
This is my great pleasure to introduce you all to Dr. C.K. Chanda. Dr. C.K. Chanda is working as a professor in the Department of Electrical Engineering, IIST Shibpur. He has earned PhD degree from the Department of Electrical Engineering, BE College, Deemed University Shibpur, India, with specialization in power systems. Dr. C.K. Chanda has over 31 years of teaching and research experience in the diverse field of power systems engineering and 4 years experience in industry. His areas of interest include smart grid, resiliency,
I have to put here.
Professor Chanda, you can start your session, sir.
Yeah, I can hear you now. I talk to the better. I'm feeling difficulty.
Thank you, madam, for introducing our today's speaker. Now we request our today's speaker, Dr. Chandan Kumar Chanda, sir, to present the topic on basics of solar forecasting. Please, sir.
So wait.
Hello. Hello.
Yes, sir.
Sir, you are audible, sir.
Am I audible? Yeah.
Yes, sir.
I am audible to you. Okay, fine.
Yes, sir. Yes, sir.
So let me start my session. Can you show my face? What is that? Where is that video part? Yeah. So am I audible? No, you said yes. I cannot hear you properly.
It is audible, sir. You are audible, sir.
It is audible. It is audible. Fine. So
Yes,
let
sir.
me start. Thanks to Tomalika Chaudhary for introduction and good morning to all of you. And you all have come to the fag end of your 3-day FDP program, Faculty Development Program. And my basic topic is the basic concepts of modeling for solar forecasting. I am having a number of slides, and within this limited time frame by 1.5 hours, and the major difficulty with me is that the data package on per day basis, I'll get only 1.5 GB from Airtel. Because of data cap, I won't able to show all the slides in details. Sometimes I have to skip my few slides. And because of that, let me give you a little introductions of this part of this, the basics of solar forecasting, why it is required and all that. Then I will go to the slides and directly I'll jump to the forecasting models and all that, if time permits and everything. So what for? We are going for the solar forecasting. But before understanding the solar forecasting in details, let me tell you the necessity of renewable energy nowadays. Why renewable energy is required nowadays? The first point is that, let me tell you in the beginning, when I will share the slides, I won't show my face because for video transmission, some distortion comes and as well as the data management will be difficult. This gigabyte management, I'll put my video up after a certain amount of time. only audio will be transmitted among us. So I'll put my video. So the point is that because of this renewable energy, why renewable energy is coming into picture nowadays? We are all talking about renewable energy. There are a lot of issues for the renewable energy. The way we are talking about renewable energy is an issue of 2010 or 2015 or 2020. In fact, if we go back 300 years back, we used to use the renewable energy. We all of us know, and we have all studied our, say, 9th or 10th standard physics. We used to burn the paper by using convex lens, using the solar energy. And they used to do like this way before 300 years. So the application of renewable energy is not new to us. But nowadays, all electrical engineers, mechanical engineers, and the people from the energy background, they're all talking about renewable energy, and renewable energy. The issues of this renewable energy nowadays, the first region, in 1970, there is an oil crisis across the globe. To mitigate that crisis, we started thinking we have to bring the renewable energy. That is the first point in 1970. And in the same time, during that decade, especially in our country, the industrial revolution started. In the tune of 60, 65, industrial revolution started. Industrial revolution means we need more electrical energy because the industry consumes more energy than the domestic or mid-sector industries. So the questions of energy came because without energy, the wheel won't able to run, wheel won't able to rotate, and we cannot derive the output or the product without that energy. So renewable energy came into picture during that 1970. Even though you are all talking about renewable energy aspects and all that in 2010, 2015, even 2020, but the issues are little old. We are discussing in a new way. We have given the renewable energy in a new shape nowadays. Now let me tell you why. Why? The first question is the deregulation issue. You all know, because I know that a lot of young budding teachers of engineering colleges have joined in this program. And this deregulation is nowadays is a topic where you can do your research. Whenever the buzzword will come, I will tell you where you can extend your research in that area. Deregulation is a new aspect, it's not an old aspect. In fact, in 2003, across India, there is a paradigm shift in Electricity Act, and from state utility, there are three types of utility: state utility, central utility, as well as the private utility. In 2003, there is a paradigm shift in Electricity Acts, electricity rules. Certain amount of energy we have to produce from the private sectors. And during that time, we have broken down our power system into three categories, three components. One is GENCO, another one is the TRANSCO, and third one is the DISCO. The implications of breaking into three components is all will take their equal responsibility. Before 2003, nobody is bothered because all are working in a government sector. Either it may be state or the central. Nobody takes care of their responsibility. No one is having their own defined responsibility. But the moment we broken into three components, GENCO people is to take their responsibility, how to generate the power and all that. Then how to push that power to the transmission side. The transmission gear will take care of by the TRANSCO people. And then TRANSCO people with their help of substation and distribution line, they'll push that power to the distribution end, and the responsibility of the distribution people to reach that power to the end consumer safely. So these are the basic concepts of splitting that happened in fact after 2003 in India. So the responsibility of each sector has come. The moment this deregulation had started in electrical sector, because we have seen this deregulation in different sectors. I can give an example, even though time is limited and my major discussion is not this deregulation area, rather than the forecasting area, but until I give a little introduction, while go for forecasting, it won't be clear to you. So there are a lot of examples of deregulation. You see in air sector, in aviation sector, even there are a lot of competition, Go Air, SpiceJet, Air, then Air India, Indian Airline, Vistara, there are a lot of, then Go Air Asia, there are a lot of lines. A lot of players are there in the air sector, and they are playing accordingly. But do you know what is the reason behind it? The reason is the competitions. If Indigo says I will give a cup of tea in that height, in 5 or 6 kilometers height in the sky, then Air Asia is telling the same price, I will give a cup of tea and 2 biscuits also. What I mean, I want to meet the competitions. The level of competition has got that into that level in air sector. Similarly, for the communication sector, it is not aware. In the signal process, there is a huge. Initially, in 1995, we can remember there is only one company in the communication side, that was Hutch, which is now being converted to Vodafone. But nowadays, there are a lot of sectors: Aircel, then Vodafone, then Airtel, then Jio, then Idea. Idea is collapsed because of their loss and profit issue. So the buzzword is the competition in the deregulation mode. So we electrical engineers from the energy sector side will lag behind. That's the question. Comes to the economics first, then the idea transmitted to the electrical engineer, why will lag behind? So electrical engineering people have started thinking deregulation, and the Act of Electricity Act has been changed accordingly since 2003, if I can remember the year correctly. So there is a paradigm shift. But if you want to stay, if that competition is to be sustainable, the main thing comes from the economic point of view, the price of the power, rather the price of energy should be as low as anything. So if you want to bring down the price of power, so you have to generate certain amount of power from the renewable sources. What I mean, if you generate power from solar energy, mainly in the form of photovoltaic cell, PV cell, not in terms of thermal energy, because we can use the solar energy in 2 modes, either in the thermal mode or in the photovoltaic mode, in PV mode. So if we generate the power in PV mode, we are quite sure next day sun will not come and extend his hand for his money. So you have utilized me, so you give me a certain amount of money for that because you have utilized me. Sun will never come. So the point is that, and this is one point, and another important point of the solar energy is not a rocket science, I can tell you. The only thing is the mindset. It is not a rocket science, it's not a high-fi technology. Only we need the PV cell, we need the converter, we need some active and passive filter to mitigate the harmonics. We need a very good control for throwing that power to the grid. I am coming point by point, and that's all. It's all about this penetration of renewable energy to this. But anyway, the way I talk is not a simple task. But the point is that if you penetrate renewable energy, certain percentage of renewable energy to the classical one, to the traditional energy, we can bring down the price. So this is one aspect. One aspect, if you want to make your business profitable from the regulation point of view, if you want to make your business sustainable mode, you have to add certain amount of renewable energy with the traditional one. This is one issue from competition's point of view, and we are thinking about the renewable energy. Second most important point I could have mentioned in the first point, our all traditional energy, whether it is on the form of solid fuel, I mean the coal or uranium or thorium, whatever it may be in the form of thermal energy coal, or it may be in the form of the nuclear energy, uranium, thorium, that is a finite quantity. If you talk about the liquid fuel, I mean the light diesel oil, the petrol and diesel, these are all finite quantity. I am having one slide, I will show you for how many years we are able to sustain with these kinds of energy. Maximum 50 to 60 years or 75 years. So those energies are finite. And we know that there is a very simple idea. If we apply those kind of energy from the finite quantity, the amount will be depleted. And time will come, finally it will be depleted. It will go away. Maybe we will use this coal, the thorium, uranium, and others, the light diesel oil, diesel, the petroleum, the other liquid fuels and all that, maybe for another 50 years, 60 years. But you don't expect this world will live for another 60 years. This is another important issue. This thing is getting depleted. So we have to, being an engineer, being in the science side, we are having the logical minds. So we have to develop an alternative energy which is very cheaply available from nature. Wind energy, solar energy, biomass, large hydel power. Hydel power is a kind of renewable energy. A smaller hydel power plant, these are all kinds of renewable energies available in nature. If we can extract that power by using our knowledge, so that will be good, and we have to go for it. There is a paradigm shift from the traditional to this side. And let me tell you in this aspect one important point. What we have seen, the third important point, what we have seen is we cannot directly correlate my third idea with the COVID-19 challenges case, but it is indirectly or directly related. There is the climate change of using this. Forget about this finiteness of this energy. If we talk about the finiteness of this energy, the traditional energy, let me tell you, there is a finiteness in the solar energy also. Sometimes we tell, sometimes we get in the form of information from a lot of textbooks, the solar energy is infinite. But let me tell you, in this delivery, it is not infinite. Maybe after 10 billion years, the solar energy will be diminished, after 10 billion years. But if we talk in terms of human lifespan, this is infinite. But solar energy, let me tell you, is not infinite. The scientists have calculated after 10 billion years, this energy will be no more. The sun will be no more. We have to search another kind of sun. We have to search. Then only able to live. But if you talk in terms of human living span, in human time scale, this is infinite. This is infinite, and think in that way. The questions of climate change. If we use the traditional energy, the climate is changing like anything. Even though this COVID-19 challenge is not directly related with the climate change, maybe due to some seafood or it has come from the bad kind of thing, we are not quite sure. Thousands and thousands of papers are coming on the basis of this COVID-19 challenges in last 2 months. Maybe already 50,000 papers have come across the globe. How to mitigate this problem? Still, it is indirectly related with this traditional energy use. And sometimes we get in a different video clips in what's the messages. The positive part of this COVID-19 challenges is that the environment has become very clean. We can see the hilltop from my Calcutta. That kind of video is now coming. You can see hilltop from your own house. If you go to the top floor, you can see. Because the environment has become very clean. No flight is moving across the sky. No vehicles. No, nothing is there. So the pollution level has come down. That may be considered the plus point of COVID-19, but that I don't want to consider. COVID-19 has created a lot of issues from academic point of view, from the professional point of view. A lot of issues are there, and we are all afraid of this. We do not know what will happen about in the next 2 years. So that's why I'm taking these classes, online classes instead of physical classes. So these are the issues of this. The climate change is very important, and this climate change is directly related to the health issue. And health issue is in a private sector, nowadays involved with lakhs and lakhs rupees. And how the country like India can afford this? The COVID-19 challenges issue, if you want to go for a COVID treatment in a private hospital, they are charging in the tune of 75,000 to 1 lakh per day. They will take 14 days, so 40 lakhs. How many people can afford 40 lakhs in 14 days? So health issue and the expenditure. So if you can reduce the traditional energy and can bring the renewable energy in our energy sector, it can give a tremendous impetus from health point of view also. But the question is, this is one point. Maybe another important point. And another fourth point is that whenever you talk about deregulation, we do not talk about the price point of view. At the same time, we talk about the quality point of view, power quality. You know what is power quality? We know at this stage. Power quality means we have to supply the power at a particular voltage level with a predefined band. It may not be the ideal voltage profile. With a plus minus 5% tolerance band, we have to deliver the power with a voltage band. We have to deliver the power at a definite bandwidth of the frequency. Because in our country, we follow the frequency at 50 Hertz. But 50 Hertz is, ideally speaking, it is 50 Hertz. At the grid, if we can maintain the supply and demand at every moment, then only it will be 50 Hertz. Ideally speaking, theoretically speaking, it is 50 Hertz. But if you talk in terms of ground reality, if you talk in terms of reality point of view, actual point of view, it cannot be 50 hertz. So you have to give a little bit tolerance in the frequency with the plus minus, and that tolerance should be acceptable by the other people. There might be a sag, there might be a swell, there might be some distortions, there might be different kinds of waves. And for all these things, some harmonics may be created from the generation side. And whenever the harmonic comes from the generation side, we calculate the THD, total harmonic distortions, on the voltage profile. We talk about the voltage whenever it comes in the generation side, because in the generation side, we know P and V is defined. P and V is defined. So we talk about the voltage profile from load flow study. We define P and V. Forget about the P. P is highly required active power to maintain the frequency. But as far as the voltage profile is concerned, we have to maintain the voltage with that range. So the question of, again, harmonic comes from the generation. We have to control the total harmonic distortion. Nowadays, again, another term has come from the load set, that is not THD, rather TDD, total demand distortions. And total demand distortion comes from the load side. And because of the, if you cannot manage the load, nowadays, even though you know the reactive power is a useless component, but nowadays you have to pay the price for the reactive power also. Another important component has come, because all private sectors are adding that price tag for the reactive power. So you have to use the reactive power in such a way that power factor should be good, as close as to 1. So the current distortion comes from the load end, and kind of odd harmonics created up to the order of 25, 27, 29, 31, 33 and onwards. If at all we consider the odd harmonics level up to 11th or 13th, that's a huge harmonic power, I can tell you. And that huge harmonic power creates a huge loss. And that creates a power quality concern. This is one aspect from traditional energy generation. Apart from that, if you go for renewable energy generation, and if we be little specific about only for photovoltaic generation, that generation is DC nature. But we cannot penetrate, we cannot integrate, we cannot throw this DC power to the AC grid directly. We need converter. Converter is nothing but a power electronic device. Power electronic device is nothing but it is some thyristor kind of switches. Thyristor is nothing but a controlled switches. Lax and lax switching actions are going on. Thyristors and IGBT. So if we use either thyristors or IGBT, whatever it may be, so this is basically a controllable switches. And any controllable switch, you know, it creates transient. And once it can create transient, it gives distortion. So all the power electronic devices itself is a culprit for generating, for polluting. Okay. One phone has come anyway. Sorry for the disturbance. So the thing is that, so this kind of harmonics will be created by the power electronic devices, because nowadays we are all hugely dependent on power electronics components, because they play a very important role in our energy sector. Even though they play in the backdrop of electrical, we cannot see those devices in the way we see the generator, turbine, transmission line, load. Power electronic devices, they play behind the screen, plays a very important role nowadays. But the disadvantage of power electronic device, they create huge amount of polluting power because of the switching actions, So we have to again, before integrating that power, before mitigating that power, you have to use the filters to mitigate that harmonic, because we are all talking about the quality of power. If you want to sell the power to somebody else, to a customer, say if I am a customer, if I want to pay the price of the power at the end of the month, I will check the quality of the power with a good voltage profile, good frequency profile, good wave shape, no harmonics power, good power factor. A lot of things I want as an engineer. I understand I want that power. If you at all work in a deregulation environment, so what we have to do, we have to mitigate that harmonics in the system. So mitigation again requires kind of filter. It may be active filter, it may be passive filter. Passive filter is generally 4 times more costlier than the active filter. So price is again coming. That price will again go to the customer. So we go for kind of a compromisation. We go kind for a judicious mixture of this idea, partly passive, partly active. We combine and go for a hybrid kind of filter. With the hybrid kind of filter, we certain amount of power. In fact, in kind of this using this hybrid kind of filter, we mitigate the harmonic by using or by correcting the power factor at the load end. Because load end nowadays is very important issue. Earlier, what happened? The generation used to follow the load. Nowadays, load used to follow the generation. The concept has come because of the demand side. Let me tell you, the way I told you, deregulation is a new challenging area. Similarly, demand side management is a new area, and a budding faculty can go for the demand side management research also. That's a new topic. How to manage the demand side, and you can mitigate this harmonics and all that. There is another. And power quality nowadays is very important issue under this deregulation. A lot of young faculties are going the power quality issues and the research also. So these are the issues for the renewable energy. So let me come back to this initial point. Basic the forecasting model. So again, another important part is their Central Electricity Authority (CEA) has developed a grid code. Grid code means if you generate renewable energy and if you want to through this renewable energy to the grid code, you have to follow certain code is here. In every year, certain code means it's a kind of discipline, kind of regulation. Some regulatory bodies have come. I just like that cannot throw the renewable energy to the grid. The technique, apart from the grid code concept, the technical difficulty is that the power is DC in nature. With the help of a converter, we have to convert to AC. We have to bring to that level where the grid will be connected in synchronizing mode. A lot of converter devices are connected. A lot of filters are used in between. So a lot of power electronic devices and active circuits are coming in between. And the most important point of renewable energy is that it's highly intermittent in nature. We cannot predict properly whether tomorrow the speed of wind will be like this, or the intensity of the sun, or the radiation of sun, or the irradiance of solar energy will be like tomorrow. So that's the challenge of the electrical engineer, whether we can forecast it or not. That's the issue. And that I will discuss a little bit with the basic model. There are a lot of forecasting models available nowadays. In fact, now I will finish this introductory part. I'll finish. I go to the sharing of slides within another 4 or 5 minutes. I'll come to the slide. No issue. So the question is, keep that water. Give me a cup of tea. Yeah. So the advantage of taking online class, don't take care. I am taking a cup of tea during my delivery. That's the advantage. I'm delivering my lecture from my place, so I can have a cup of tea, what is not feasible in physical classes. So that is the point. So now we have to go for the slides. So to maintain that grid code, and let me tell you one more important thing is coming nowadays in the papers. The traditional energy is coming in the form of rotational inertia. That is in the tune of 80%. I'll show you the slides. And 20%, I'm giving a little old statistic, 2018, 20% renewable. So the inertia energy is 80% and non-inertia is 20%, that kind of synchronization is again a difficult task. That it may be a good, very good topic for PhD research, for research area for the budding engineers, I can tell you. How to connect non-rotational energy with the rotational energy in the grid. So these are the issues nowadays. So let me jump to my main topic, and I'm trying to share my slides. How to forecast the load, because this nature of the renewable energy is little intermittent. But if we can predict a little bit, if we can forecast a little bit, it will help us. And not only that, say about a fortnight back, 15 days back, we got a storm in the eastern part of India that is known as Amphan or Umphun, depending on the channels, Amphan. And the prediction is absolutely right. Even in your Maharashtra, few days back, there is a prediction, Nisarg storm it's supposed to come, it came. Even though the landfall was not exactly in the place they predicted, but it came. But it was not devastating like what happened in Amphan in Bengal. So nowadays the prediction is working. I am delivering lecture in my outside, the heavy rain is going on, and they predicted 4 or 5 days that there will be heavy rain from 10th onwards, and the rain is going on here. So this prediction, because the scientists nowadays can predict with the help of meteorological data and with the help of mathematical model, because in every engineering, inside that the mathematical model is working. So now let me go to that basic mathematical modeling of those slides. But before that, I'll skip the 11 slides very quickly. I have described all the slides. So directly I'll go to 13 slides by skipping one by one. So let's share the slides. Yeah. So next slide. Yeah, next quickly. Oh, let me. Yeah. So this is the introductory part I have covered. Hope can you hear me? And can you see the slide sharing?
Yes, sir.
Yeah, okay. Sometimes you unmute and respond yeah. So this is the introductory I have over. I'm skipping. This is the current that I wanted to explain in details. Current scenario power, 80% is coming from this, 20%. Year-wise growth in renewable. This is basically a statistical base. This is not the domain of the discussion. Coal, oil, natural gas, for how many years you are going to get it. I already described coal 75, 35 and all that. Here comes the sun. Let me tell you one point. One important point is that we have to go for a paradigm shift in clean energy production, because the time is very tight. You want desperately to stop the climate change. And another important point I wrote for you, we cannot wait up to the last drop of oil, last ton of coal or last kilogram of uranium. And let me give you one statistics, 1,74 trillion watts are falling from the sky at any moment of the earth. If I talk in terms of literature, language, so thing is that what power we are extract, what power is coming from the sun in every hour, we can manage this whole planet, 210 countries for the whole year. So 1 hour power generation from the sun can manage this whole earth for whole year. So imagine what you are doing now. Payback time is also gradually reducing day by day because of advanced research in the field. Technology is going leaps and so these are the things So the deployment of solar-based photovoltaic cell is very important, and the most important issue of this solar energy is the variability and uncertainty of solar power. So the thing is that we have to forecast. The thing is that, however, one of the most effective and least cost ways to integrate solar, particularly at penetration level, currently experienced is to forecast the expected power output and use that to more reliably and efficiently operate. We are going for forecast. Why we are going for the forecast? We are going for the forecast because of the grid security, because of the maintenance of the grid, because of the balance between the supply and demand. So these are the factors. The most influential factor in forecasting the power output of a given solar power plant is the solar radiation incident at the side of the plant. Say I want to measure the solar radiation in my place, Calcutta, and I can predict what will happen in the month of August 2020. If you get able to develop the model, and 90% of our model will work nicely, apart from the meteorological data. That is true. So forecasting of the irradiance at the site of the, what is irradiance in solar? Irradiance, is nothing but the radiant energy per square unit area that we define the irradiance. And conversion of that we are not interested in the irradiance. We are talking for irradiance in terms of forecasting model, but we are not interested with the irradiance. What we'll do, we'll convert all the irradiance forecast to the power forecast, because we finally need power or energy. So this is the calculation of irradiance that I am not also interested. Irradiance generally, if we take the surface area of any part of the earth per meter square area, it comes around 1367 watt per meter square. But if you take the different part of this earth surface, it might come 800. So on an average, it comes 1000 watt per meter square. This is the kind of irradiance we get, and this 1000 watt per meter square, I hope all of you know the unit of irradiance is sun. 1000 watt per meter square is known as one sun, SUN sun. What I mean, if I take half sun means 500 watt per meter square. It does not mean we have broken the original sun into two parts. It's not that. We cannot break that original sun. Half sun means 500 watt per meter square, unit is one sun. SUN, sun. The unit of typical irradiance is one sun. That sometimes comes in the gate exam. What is the unit of irradiance? Sun. 1000 watt per meter square. That calculation is there, that I'm not going. So we have to calculate the irradiance in a particular distinction. So therefore, let me come to my general description. Solar forecasting requires the blending of knowledge from the meteorological perspective and understanding of predictive modeling techniques. So forecasting. So this is my discussion, and hope you are now enjoying the slides. Predict the next number is the pattern. Let me start with a small matter. Prediction and forecasting is mathematics. Now I am leaving my electrical engineering part, coming to math and stat combinations, because any kind of model needs huge amount of math. So I'm coming to statistical or the mathematical part rather than the electrical engineering part. For the timing, I'm switching to mathematics side. Predict the next number. Hopefully you are able to see the answer A is 33.7. Answer B, you see, that is in progressive manner, in arithmetical progression, 2.5, 4.5. So next will be 12.5. Similarly, for the answer C, it will be 9.0. So you can predict for the next future. This is 3.7. You see, this is 12.5, 8.5, 12.5, and this is 9.0. So this prediction you can. So if you can predict the thing, how we are predicting, because we are predicting from because we know mathematics. If it is all 3.7, it will be 3%. Once we understand AP arithmetic progression, we have some knowledge about arithmetical progression. It is progressively increasing by common difference to it is 12.5. If we have a little knowledge about the similarity of the number theory, we can predict this is 9.6. So let me come to the model. What is time series? Time series means, let me tell you, from here the model starts. Time series means the data or the demand data or demand or data, the way you define what depends on time. That is called the time series data. I can give one or two examples before going to the model. Say the selling of ice cream becomes more in summer seasons. The selling of sweater becomes more in winter seasons. We cannot think otherwise. Selling of ACG is more in hot seasons. So all the parameters of all these data are dependent on time. So this is a time series data. So our solar forecasting irradiance is absolutely a time series analysis. It depends on time. So I'll go for 2 or 3 basic model. Maybe time will not permit, my data will not permit. I'll go 2 model. So remember, whatever the data I'm analyzing, all the data is basically a time series data analysis. All the data depend on time. So let me come to the next slide on the forecasting. Here I will take 5 or 6 minutes time to listen. What is forecasting exactly? If I ask in the physical class, if I pose this question to a group of students, what do we mean by the term predictions and forecasting? The students answer basically said this is a kind of an estimation. That's true. Forecasting is nothing but a kind of an estimation. Estimation may be wrong. It is not that estimation may be a perfect calculation. Maybe plus minus 5% tolerance will be there. Kind of error will be there in the estimation, but this is an estimation. But again, the question, why this estimation is required? The estimation is required for us, for electrical engineers, because the productive planning and capacity planning. How much solar energy you can penetrate to the grid to make the grid secure and to maintain the grid code, that is the capacity planning. How much PV cells are to be installed, that we can go estimation. We can estimate how much PV panels we can install in 2025 such that it can maintain the grid code as well as it can maintain the grid security. We can calculate for 2025, even though we are in 20. So even though this data is a little old, what 2004, but instead of 2004, you try to read as 2014, then instead of 2009, you try to read as 2019, and as if we are predicting for 2010, you try to read as 2020. We are predicting for 2020 in the month of August. You want to predict. June is going on, we want to predict for the after 2 months we want to predict. So these are the data say available. Say for a particular place, say for my place, the Sibpur IIST, if I consider this my institution campus, only the small campus, and the irradiance if I consider as 25 sun, the unit of, I mean 25 into 1000 watt per meter square. So this is the amount of irradiance in my campus, 131 acres campus, this is this 25 sun. 2005 we measured, that is 32. 2006 or 2016, the way you calculate 24, 28. So I took only 6 data of irradiance in my campus, IIST campus. 2015 this, and let us calculate for 2020. Instead of 2020 calculate, this is the irradiance. And if I pose these questions to a class of students, so this is the irradiance factor or irradiance estimations, or this is the, nowadays we can measure the irradiance with the help of a machine. The machine is available, we can measure it. We are having a very good green energy department, they are having the equipment, they can measure it. So if we ask my students what should be the irradiance, what he cannot measure now with the equipment will be 2021 or 2022. What should be the irradiance? So he cannot use his equipment because 2022 has not come yet. So he has to go for some forecasting model. And if I pose this question to a class of students, the first student will answer 27. F is the mean I forecasting and 27. So let me go a little bit fast. Sorry, go on. Hello, just one important phone has come from the. I'm continuing for after a minute. I just put it off. Come to that slide. I did not to stop during this. Yeah. Make a full slide F5. Hello?
Yes, sir.
Is it audible? Yeah, because of some disturbance in the network, the thing is happening, some instability in the network and one phone has come also. Anyway, so let me continue. The first student answer is 27. He has answered in this manner. Just go for the full slide. This is okay. No, let me go for F5. Then it will be. Oh, F5 is not. Okay, let it be. Oh, cannot make it.
Sir, kindly share the cell.
This is okay because I am not able to. No. Yeah, this is the full slide, I think. Yes, this is the full slide. Next slide is not coming. That is the biggest. Now it is coming, Next slide will come. Yeah, next slide will come. No, it's okay. Because of some technical issue, I stopped for a few minutes. Anyway, the second student will answer. Let me explain the answers of the first one. The first student, what he has done for forecasting for 2020, he has taken all the data and he has averaged it. He has taken the arithmetic mean, what we have learned in our 7 or 8 standard. For the second student, what he has done, he has taken the last 4 values. He has taken the last 4 values. He has ignored the first 2 values. For the second student, he thinks that the 2014 and 15 data is a little old. He wants to take the recent data and he has taken the average and his answer is 26.25. In some sense, he is also correct. If we look at the answer of the student number 3, this forecasting 28, what he has said, what he has done, he has ignored the last 4 data, 25, 32, 24, 20 he has ignored. Instead of that, he has considered the last 2, most recent 2 data, and he is finding some kind of trend. This 2019, 27, 2018, 26, and 2020, to him or her, it might be 20. It's finding some kind of trend in the data in each forecasting. This is his forecasting. In case of fourth student, what we find, some other factors. It does not believe all these average of last 4 values, some kind of trend, some kind of arithmetic mean. He finds some other factors are responsible, and on the basis of that, he forecasted the values will be 30. In case of fifth student, he is interested for all the data. He is finding a kind of trend, increasing and decreasing trend. First data 25, mean 25, then 32 increase, then decrease, then increase, then decrease, then increase. Then he thought that it should be kind of decrease. 26 is decrease, 27 increase, then it will decrease. So he's seeing a kind of pattern, kind of trend, decreasing, increasing trend in his data, and he's predicting from his point of view. Sixth student has answered. He has taken the 3 data and he has gone for the arithmetic mean. Seventh student, he has not done like this way. What he has done, he has ignored the first 3 data, older data. He has taken the last 3 data, and to him, 28, he has considered the last 3 data, 28, 26, and 27. And can I give this? No, the cursor I want to see.
Sir, cursor is
So initially, this was 20. He has considered the 3 data. Cursor is difficult. Anyway. I think this one is good. I think this is coming.
Sir, here that will come.
Okay. Sorry, let me continue. So remove this thing. There are kind of technical disadvantages again. So some markers come. So this is okay. So has considered last 3 data, 28, 26, and 27. And out of these 3 data, 7th student considered 28 is the oldest, 26 is older and 27 is the recent data. So has given certain amount of weightage for 27, that is 3, and progressively decreasing weight for 26 2, and given weightage 1 for 28. So what he has done, 28 into 1 plus 26 into 2 plus 27 into 3 upon 1 plus 2 plus 3. So he has gone for weighted average for the last 3 values. So it is a kind of an average, but this is a weighted average he has taken. And for the last student, 8th student, he has told 26, his logic, he has reasoned out like this way, his logic is this, maybe out of the 6 data, the 6 irradiance data, 32 might be outlier. He is considering, suddenly there is no similarity between 25, 24, 28 and 26. He considered this 32 is a spy kind of thing. It is an outlier. So he rejected 32. After rejecting this data 32, he has taken the mean or average of all these data and he has got 26. If you go on asking this question to a class of 60 students, we will get 60 answers. And all the answers are valid. All the answers are reasoned out by the respective student. All the answers are very much scientific from their point of view. Now we have to reason out. Now we have to put the adjustment. What are the models are coming from the answers? The first model, if we look at these answers, we can find all the answers are basically the average around the center value. Basically, all the results are kind of average value, and the value is lying in between 25 and 27. That is the thing. It's basically centered around average. And let me say this way, this is the answer centered around average. And this gives 4 basic models. Hopefully from this answer you have got it. There are 4 basic models are there from these 8 answers. The first student's answer is average. What are the advantages of this? This is a simple average or arithmetic mean. This is again a very good technique. And another one is the average of last 4 values. This is called K-point moving average. K-point moving average means we are ignoring few data. This is called a moving average. MA technique, moving average. K-point moving average means we are considering from the last point to the points we are ignoring. That is the K-point moving average. So in case of student number 2, the moving point average is 4-point moving average. The value of K is equal to 4. In case of 3, it is not an average, it is a kind of a trend increasing 26, 27 and 28. 4 is other factors. Hopefully if you have studied the statistics in detail, other factors come under causal models. I am not going to explain the causal models in details because this is not in my purview for discussing here. Causal model is a very good model for this irradiance calculation. That is a kind of a model, is a huge amount of similarity between the linear regression and non-linear regression type of model. So this is a... Hello? So this is another model is K-point moving average. Another one is there weighted average. We can give for weighted average for all the data. I can give weight for 25 for W1, for 32 W2, for 24 W3, right, 28 W4, 26 W5, 27 W7, then W1 into 25, W2 into 32 this way, and I can divide by W1 plus W2 plus W3 plus W4 and all that. So this is kind of weighted average. Or I can give a numerical example. I can give weight for 25, 32, 1, 1. I can give weight 24, 28, 2, 2. I can give weight 26 and 27 as 3, 3 and divided by all the weights. So that is a weighted average. But if I take last 3 data and give weight, that is called K-point weighted moving average. I have not considered, I have given the weight for the old data because for few students, these old data are not that way relevant for prediction. it can give a good reflection to the forecasted value according to his perception. So he wants to put 0.8 for 25, 32, 24. He is ignoring means he is giving certain amount of weight and that weight value is 0. So this is a K point weighted moving average. So let me explain you once again. Simple average, K point moving average, plain weighted average, and K point moving weighted average. So 4 basic models are coming to forecast for the solar. It is not true for the solar forecasting. The way I'm explaining it, these mathematical models are exclusively true for calculating the solar. It's not true. You can go for wind power model. You can go for any product. You can go for sales of automobile. You can go for sales of mobile phone. You can go for the data pack in the communication sector. You can go for any kind of thing if you go for production planning and capacity planning. But in our case, as an electrical engineer, are talking from forecasting point of view, from solar point of view. So these are the 4 basic models we got. But definitely in the meantime, in the back of our mind, one thing has come: what should be the weight? How should I? The way I have chosen the weight for 28, 26, 27, for 28 to 1, because this is oldest data. For 26 to, this is little older. 27 is the recent data. I want to give more weightage because we expect more reflection will come for the next year, 2020, 2021. That kind of thing we are expecting. So, what should be the weight of this, and how to decide the weight? So for that reason, we go for a level model. So this model is known as a level model, or sometimes it is known as a constant model. What is this level model or constant model? F is the forecast, A is the constant, and epsilon is the noise. So let me come back to the previous slide. If you consider it a constant model or level model, then why the answer of 8 students are different? Definitely the question is coming in your mind, why 8 students are answering in a different way? If 60 students are there, why the 60 types of forecasting is coming for the year 2020, and which forecast will follow? Out of 60 answers, which one will accept it? The questions are coming like this way. So the issue is, there is a little variation. If you consider, if you at all you take this, the first one is the correct one, F27 is the correct one. The first student is given the correct forecast for 2020, and if you consider 20 is a 20 is a 27, then 2021 will be 27, and the remaining years will be 27. So no need to go for forecasting. So what I mean, there is a little inherent variation among the data. It's not that in every year the data will show some consistency. There is an inherent variation in the data that is known as statistical variation in the modeling. So we find the statistical variations in the modeling, and that statistical variation in our modeling language, we call it as a noise. And if you are fortunate enough, if you take 10,000 data, and out of 10,000 data, 5,000 are positive noise and 5,000 are negative noise, they will cancel each other and the thing will become 0. But in data analysis, in statistical analysis, it never happens. 50% data will be positive error and 50% data will be the negative error. It never happens in reality. So what happens? We take the spread out value of that disturbance, what we call as a gap, from the mean value. From the mean value, we take the spread out. What is known as a variance. Sigma square is nothing but the variance. What is variance? You know from the statistics. That is a spread out from the mean value. We go for the squaring of that. That value is nothing but the standard deviation. That is the deviation. If you go for squaring, that is the variance. And because of the inherent statistical variation, the noise range will become 0 to sigma square. So this forecasting model can be represented by F is equal to some level value, some constant value, plus some statistical noise, which will be ranging from 0 to variance, 0 to sigma square. Now again the questions comes, how to calculate the statistical variation, or how to diminish or decrease this range 0 to sigma square. If you can decrease this range 0 to sigma square value, our prediction or forecasting will be little accurate, will be much more accurate. Otherwise, all forecasting having certain kind of error. no forecasting is absolutely correct, error-free. It cannot be. And that's why it is an estimation. That's why it is forecasting. So we want to reduce that, and to reduce the range between 0 to sigma square, what we have to do, we have to go for correct predictions of the weight. So let us consider these 6 data. I am considering these 6 data and how to calculate or how to give the weight for the different demand data, progressively increasing manner or progressively decreasing manner. The way you want to look to the data, whether it's the recent data or the oldest data, with the help of simple exponential smoothing technique. I hope a lot of professors probably know this technique. This is a trend model I explained, simple moving average. And now let me explain this exponential smoothing model for the level data. Let me tell you, this exponential simple, this is kind of a simple or single smoothing model for level data is not exactly true for the trend data. If time permits, I'll come to trend data. I have to cover trend data also. And in that case, I may exceed 1.5 or maybe 2 hours. I am not quite sure. Till my data permits, I'll continue. So data is there. No? So if data is there, I can continue. So exponential smoothing. I have taken the same old data, 25, 32, 24, 28, 26, and 27. And the model, nowadays all students for their research, they are going for optimization kind of technique, optimization technique. So this is one model for exponential smoothing model for the level data. Ft plus 1 is equal to alpha dt plus 1 minus alpha into ft. Let me explain. This is an empirical formula. This is not a derived one. Let me tell you. This has come from by induction kind of approach. What is F? F is nothing but the forecast, the first letter of forecasting. D is the demand of the data, and alpha is the smoothing constant. And you see, in this modeling, there are 2 components. One component is the data or the demand, and another component is the forecast. So Ft plus 1 means we want to predict or forecast for t plus 1 period. So we are having the 6 data. We want to calculate for 7th period, say for 2020, 2021, it will be F7 because 6 data are, yeah, put a question mark, that's right. So 2020, this question mark you want to fill up by Ft plus 1. So Ft plus 1 will be F7. So, and what is alpha? Alpha is the smoothing constant. I am coming to the smoothing constant bit later on, how to determine the smoothing constant, the way we define the membership function in a fuzzy math. The way we define for particle form optimization, PSO technique, we go for a membership function, and the way we define the membership function, here it is the alpha is kind of a membership function, is a kind of a smoothing constant, and how to define it, I am coming later on, but let me proceed with this mathematical model, exponential smoothing model, Ft plus 1 is equal to alpha dt plus 1 minus alpha into Ft. I am little bit fast in explaining, hope you are able to understand. If you cannot understand, you can raise your questions in between, I don't mind, or at the back end, I can take some questions from your end. I am little fast because of the data limitations and time limitation, I am little fast in my explanation. Hope you are understanding. Ft plus 1 is equal to alpha dt plus 1 minus alpha t. So, if I want to calculate F7, if the slide permits, yeah, F7, it is as per this formula, it will be alpha d6 plus 1 minus alpha into F6. So alpha d6 will remain as usual plus 1 minus alpha F6. I can write as alpha d5 plus 1 minus alpha into F5. And with this way, I can proceed. Similarly, if we proceed this way, the final expression alpha d6 plus alpha into 1 minus alpha d5 plus alpha into 1 minus alpha square d4 dot 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 plus the last term 1 minus alpha to the power 6 into F1. F1 probably is not visible from this side. This is F1 because the F6 is gradually decreasing to F5, then F4, then F3, then F2, and F4. So, if we want to calculate F7, this is the modeling, this is the mathematical modeling. We know all the data, D6, D5, D4, D3, D2, D1 are in our hand. From the previous year, from the measurement devices, we can get the data. F1 is a kind of forecasting, and that is available by the 8 students. From any 8 student, we can take any forecast, consider that forecast is the correct one, we can go for that. And in one shot, in one go, we can either calculate F6. After calculating F6, we can calculate F5. Then the other way around, once we can know F1, we can calculate F2. Once we can calculate F2, we can calculate F3. So similarly, you can calculate F2, F3. Considering alpha is equal to, why I have chosen alpha is equal to 0.2, this membership function is 0.2. I'll explain it later if you go for a real design. And F1 I have considered 27 as a simple average. The answer I have taken from the first boy. The arithmetic mean what you have learned in your class 8 standard mathematics or 7 standard, that 27. But this 27, F2 is say 26 point something, does not matter much, I'll explain. Whether it is 27 or 26.8 or 26.36, it does not matter much at all. I'll explain to you, and alpha is equal to 0.2, I'll explain. So we can calculate with the help of that model. F2 is equal to 26.6, F3 slightly better model 27.68, and finally F7 has come at 26.94. Or at one go, at one shot, we can calculate by using this alpha D6, alpha 1 minus alpha D5, we can calculate in one shot the value of F7, we can calculate it. We can calculate stepwise, or we can calculate in one shot also. The question is, now let me come this membership functions of this modeling alpha. In our modeling, instead of membership function, in fuzzy math, we call it as a membership function. In this exponential smoothing technique, we call it a smoothing constant, alpha. This is a different name, but the function is a membership function, alpha. This alpha depends on two values. This alpha depends on two conditions. This condition is not written here. I am trying to write with my stylus. This alpha should be lesser than 1 and greater than 0. Alpha should be greater than 0 and lesser than 1. Why? Definitely the question is coming in the mind, sir, in this type of model, why will consider alpha lesser than 1, greater than 0? Because you check the mathematical modeling, the mathematical function of forecasting ft plus 1 in exponential, it has the two components. One is the data component, demand component, other is the forecasting component. And we want both the component will contribute. Forecasting component, what we have decided from the student 1 or student 3 or student, that contribution will come. And the contribution will come from the previous data. Until and unless we are having the previous data, how we can predict for the future one? We need data. So both the components should contribute. Now we consider if alpha is greater than 1, alpha becomes greater than 1, ft becomes negative. The contributions of forecasting becomes negative. And that negative contribution is adding to the demand that you don't want, and the whole forecasting will be erratic, full of errors. Error and errors will come. Again, if we consider alpha is less than 0, I mean negative, the demand contribution is more. What are the data we collected in the previous year will be absolutely useless for us, or that is contributing in a negative manner. So if we think both the demand data and the forecasting data contribute in a nice manner, in a reasonable sense, in a logical manner, the alpha should lie between 1 and 0. Hope I have made you understand and you are getting this point. This membership function of this model should lie between 1 and 0. The moment we accept this idea, they said, yes, we have accepted. The alpha lie between 1 and 0. What should be the value of alpha? Alpha should be very low, it should be nearer to 0, or alpha should be very high, it should be nearer to 0. Whether we should take alpha as 0.8, 0.9, or we will take alpha as 0.5, or we will take alpha 0.1 or 0.2. In my calculation, I have taken 0.2. The answer is the value of alpha should be more close to 0. And you see, I have considered it as 0.2. It should be more close to 0. Now again, let me justify this answer. Why alpha should be more closer to 0 values? Why? Let me come to the earlier slide. Oh, these are not the things earlier slide. Yeah, not this slide. If alpha, let me tell you, let us think in a method of contradiction. Let us think alpha is 0.8. The value of alpha is approaching to 1 and alpha is 0.8. If alpha is 0.8, you see, if I put in this side, bring this stylus here, alpha is 0.8. If alpha is 0.8, so 0.8 into recent data plus 0.8 into 0.2 means 0.16. 0.8 into 0.2 means 0.16. So altogether is coming 0.96. So you see, out of 6 data, the last data, the recentmost data, and the next and before that data, D6 and D5 is contributing 0.96 of the total forecasting. That you don't want. We want all the data should participate in this contribution, in this forecasting. All data should participate. And what is your objective in this modeling? Our weightage, this alpha is nothing but the weightage. This weightage will be such that this weightage will be go on diminishing or progressively decreasing to the older data. D6 is the most recent data, and D1 is the oldest data. So we want to give a weight. What we could not able to decide in our earlier models. Here we can decide by the single or the simple exponential smoothing technique method. Here the alpha is 0.2. In the next case, weight is 0.16. You see, in every case, the weightage is gradually, progressively decreasing to the oldest data that we wanted. And another thing, we have satisfied, we have taken all the data. We have not ignored any data. We have not any biasness towards any data. That recent data is very good. Okay, the recent data is very good. We have given more weightage. We have taken the oldest data, also less data, but we have given least weightage. But we have not considered it as G0. We have not ignored at all. So the advantage of considering alpha is equal to 0.2 is that now the question again, how we will choose this alpha? As you have told, alpha will be approaching to 0. It should be 0.1, it should be 0.2, it should be 0.3. No. This 0.1, 0.2, 0.3 will come from some consciousness. Few researchers, few experts will sit together. They'll discuss among themselves. They'll take a collective decision. In this modeling, if you take alpha is equal to, instead of 0.1, if you take 0.15 or 0.2, sometimes the collective decision is better than an individual decision. And that's why you go for a meeting. Why you go for a departmental academic committee meeting? Rather, the head of the department could have taken all the decision. The collective decision is always good because all the people are giving their opinion. Finally, we'll take the best opinion out of that. So the thing is that the people will sit together, whether they'll choose 0.1 or 0.2, 0.2 from their previous experience. So for forecasting, data is useful as well as the experience is useful. That is very, very important issue also nowadays. So their experience. Okay. So that the previous experience, people's experience, and the approaching value of alpha weight will play a very important role in deciding the values of alpha. I hope this alpha depends on this membership function should lie between 0 and 1, and I hope you have understood very clearly why alpha should be approached in the smaller order. It's the membership function in fuzzy mathematics also in the lower order also. The reason is that is the only reason for choosing this kind of modeling. And another important issue, let me tell you, I cannot write with the help of stylus pen because that is a very big mathematical expression. Whiteboard is not available here right now. What is the weighted average? In weighted average, I told you, weight will be multiplied by the data divided by upon summation of all the weights. Summation of all the weights. So in our case, you see all the weights, alpha into 1 alpha, alpha into 1 minus alpha square. These are gradually diminishing and non-integral in nature. It's a decimal value, 0.2, 0.1, 0.6, then gradually diminishing and all that. If you consider for 6 data, imagine these coefficients alpha into 1 alpha into 1 minus alpha square, alpha into 1 minus alpha to the power 5 will come in the denominator for this data. And what is your observation? We have learned in 11th standard mathematics, GP series, geometrical progression series. You see alpha plus alpha into 1 minus alpha into 1 minus alpha square plus alpha into 1 minus alpha to the power 5 is in GP series, where alpha is the first term and 1 minus alpha is the common ratio. So imagine I have taken only 6 data for calculating, but for solar irradiance, we will able to collect thousands and thousands data, lakhs and lakhs data from the meteorological department. So if you consider this model for n number of data, so we can write alpha dn plus alpha into 1 minus alpha dn minus 1 dot alpha into 1 minus alpha to the power n minus 1 d1 plus 1 minus alpha to the power n into f1. So that should be the function for n number of data. I've expressed for n number of data. And imagine if this value of n is very, very large, we know infinite GP series also. What is the summation value of the infinite GP series? It is nothing but the first term divided by 1 minus r. If a is the first term, a upon 1 minus r is the infinite GP series. So in our case, the first term is alpha upon 1 minus, common ratio is 1 minus alpha, 1 minus alpha, becoming alpha, alpha, numerator, denominator coming out, so it is becoming 1. 1 minus alpha. It should be 1, right? 1 minus bracket 1 minus alpha. Alpha, right? Alpha 1, yeah. Alpha is the first term divided by 1 minus common ratio 1 minus alpha. So it is becoming 1, and that you want also. So imagine if the data are more in numbers, thousands and thousand data are there, we need not write for the denominator. You find here that there is no denominator. And so in that case, this model is a very good model. In case of a moving average, moving weighted average or weighted average, some denominator is there, but here the denominator is coming as 1 because the data are large. And another important observation we have found, 1 minus alpha is nothing but 0.8. I have considered alpha is equal to 0.2. So 1 minus alpha is 0.8. 0.8 to the power infinity, I mean 0.8 to the power 1000, it has become 0. So I told you in the beginning, whether I take the forecasting value for the student 1 or the student 6 or student 7, it does not matter much. If f1 becomes 27 or 26, it does not matter much because 1 minus alpha to the power n, this is a fractional value, to the power very large value, very, very small, we can consider it as 0. So contribution of weightage 0 into f1 is 0. So frankly speaking, the contribution f1 is almost negligible. So whatever is predicted by the student number 1 and student number 8 does not matter much. We are completely almost dependent on the demand values only, and we can forecast. And this is a very good model. Let me tell you for this exponential smoothing coefficient model for this. So I can take, before going to another model, because what is the time now? 11:50. 50. Oh, 11:50. Anyway, so I want to take 1 or 2 questions from your end if possible, because I want to switch to another model that is a trend model where some consistency is not there. Data will not show some constant kind of thing or level kind of thing. Rather, the data will show a trend. So before that, before finishing this part, I want to take 2 or 3 questions from your end. If any question is there, I can interact. You show my face now. I am interested to take 2 or 3 questions from this side. So any questions from here and from this model? This is a very good model, I tell you, because even though these models are very, very simple model or basic model, why I am delivering lecture on basic model, the reason is that once you understand the basic models very clearly, you can jump to any advanced model easily. In fact, depending on what factor, yes, very good questions from Miss Rekha, CM Rekha. That's a good question. That is true. So, can you hear Miss Rekha? Rekha, you unmute yourself and you talk to me. This is the biggest questions in this smoothing exponential model. And that's why we have brought this exponential model, this alpha. I told you in my class, alpha should lie between 0 and 1. Why? Because if we consider the value of alpha is more than 1, the contribution of forecasting will be negative. And if we consider the alpha below 0, the contributions of demand will be negative. But we want to keep contributions of both. So the contributions, as we want to keep contributions of both, alpha should lie between 0 and 1. Again, the next question is, if it is between 0 and 1, we can create thousands and thousand numbers. 0.001, 0.002, 0.003, crores and crores numbers we can create. But what should be the value? The value in my example I have taken 0.2, but this weight we have to decide in such a manner, this membership function, rather in the language of optimization technique, the value we will choose in such a manner, the contributions of the demand will be more, and all the demand data we want to take for our forecasted value, the forecasted value will be such that all the demand data should be there, and the weightage will be progressively decreasing to the oldest data or progressively increasing to the recent one. That is our motto. We will give more weightage to the recent one because the recent data is more relevant to that the data. Because if you want to calculate how many mobiles are nowadays are sold by the company, we'll collect the data for the smartphone, not for the old phones of 990 rupees. We always collect the data of the smartphones are now being sold in the market by the people, by the shopkeepers. We'll never go for the old phones how much they're selling, because this is little old. Because the old data is having a little relevancy to the forecasting, but not that much. So we'll contribute, we'll give the weightage in such a fashion, the oldest data will very small weightage, and the very recent one will get the highest weightage, and that weightage will between 0 and 1 as per this model. Because a lot of models are available, I am not getting enough time. Here another lecture will be studying from 12 o'clock. So that's why I wanted to do, because I wanted to explain another model that is very important model, the linear regression model. There's no linear regression, then seasonality, but time in order. It will take minimum 3 or 4 hours to explain. If all the models, the basic models, minimum 4 hours are required. Anyway, so that way you select, and not only that, the experienced counts a lot also. If all senior most people comes together, and if they sit together, and if they're having a little idea about the weightage and the membership functions of the fuzzy mathematics, they'll decide let us consider alpha will be between 1.5 or 1.6 and 0.2, and it will give a very good forecast, and we'll forecast accordingly. Miss Rekha, am I clear to you? Depending on what factors, yes sir, I agree.
Suppose if outlier.
Yeah. Yes, Rekha, that I have already explained. Yes. In case of the last student has answered that one, if I come back, if I cannot come back to my slide because I am now showing my face now. Now I am the video mode, so that you can see my face and I can interact with you also. Where is her face? Rekha's face, can I see? No. Okay. That's not required. It's not okay. No issue. So the point is that the 8th student in my presentation, if you take the screenshot, okay, forget it. Otherwise, G paradise, let it be like this. The point is that he had simply removed that spike from that. If there is, it's a very good question. If there is an outlier, but the question is that outlier data is very few. Let me tell you, we have faced this Amphan kind of storm in this year. So Amphan we can consider as a spike or is a kind of outlier in a kind of Amphan is a devastating storm. It happened in our state in 15 days back. In the next very day, Prime Minister visited our place, how much loss incurred and all that. But it is not that Amphan will come every month, every year. That Amphan came after 60 or 70 years. So in case of any data, what I mean, the irradiance in your place, Belagaon or Belgaon, whatever it may be the pronunciation, it may, if it is in your campus, if it is 32, it is not that in one fine morning, in one day, it will be 232. It might happen in one day, instead of 32, it may be 42, 48, but it's not that on average basis 32, 33, 28, 26, some consistency you'll get. It's not that you one fine morning inside your campus, you'll get 132. It might happen because of some planetary motion. If because this solar irradiance, I could not get any time to explain it. This solar irradiance depends on a lot of factors. Because your sunrise time is very important, sunset time is very important, relative humidity you have to consider in this modeling. That I have not gone for this relative humidity. What is the air temperature? What is air pressure? These are all parameters you have to consider for the linear regression and this kind of model. But whatever is the model, suddenly the weather cannot change and suddenly you not get the irradiance. So if the outlier term comes suddenly at once, say out of 10 years in one day, that outlier term or the spike comes, you simply ignore it. Still your forecasted value will be very good, I think. I think this is the answer. Suppose if outliers are outlier not comes in a very frequent manner in weather condition, it comes it comes in very rare, and in that case you simply or it might happen if outlier comes at all in very frequently. Let us think in other ways also. So outliers are coming in a very, very frequent manner. If outlier comes frequent manner, then we will have a look of that outlier terms. Once you call it is outlier means we can remove that outlier. That's why it is outlier. We can take out that term from that. That's why it is known as outlier. But if the outlier is a fashion, then we'll try to see a trend in that outlier. We'll go for a different kind of seasonality matrix model. There are a lot of models. Because that model, I mean the double exponential technique model is a Holtz model. Holtz has given a very beautiful model. And then the seasonality index has given by Winter. Winter is not the name of a season. It is the name of a scientist. Winter has given a very good model, Winter model. So with the help of a Winter model, Holtz model, the combination of Holtz and Winter model, don't get confused, Winter is a season. Even though it is a seasonality model, but delivered by the name of the scientist is Winter. So Winter's model, by Holtz model, by combining Holtz and this model, by combining this, we can tackle this outlier data. But outlier is outlier. We can remove it. Oh, you got the answers. So any questions? I'm getting a few questions from your end. I expected more questions.
Participants, any questions?
Yeah. I expect more questions from here, but I'm extremely sorry I could not able to explain the other models because it is basically the PPT is basically for 3.5 hours or 4 hours. I have explained one model only, but the more interesting model was the next model. The Holtz model was very interesting. Yes. Oh, anyway, that's good. Dr. Prasad has given me thank you. Thank you means it is the end. So thanks. So no more question means I'm in the happier side. Always the lecturer is always in the happy mood if there is no questions from the other end. That's good. Thank you. Thank you all. Thank you all.
Thank you, Dr. GHP department speaking. So, very good speech from your side. That is, you have explained the basic model. Still, you have got some of the non-linear models and the details during the analysis of solar modeling. And then we hear from you in some other time. We'll go definitely you want to once again like Skype or in person after doing the COVID situations. Okay, once again I thank all of you, J College of Engineering and Department of Electrical Engineering. Thank you, sir. Professor
Thank you, sir, for a very knowledgeable session and enlightening us about the basics of solar forecasting.
Thank you so much, but the main point is that I could not able to go to the latest models and all that. This is a very, very basic model. But anyway, because the laptop time, because the another interesting model was their Holtz model, but I could not able to explain it. Sometime I will deliver a lecture on Holtz model. Anyway. Yeah, thank you
very much, sir. Thank you.
Okay, thank you. Thank you so much.
I request Dr. Devraj Sarkar.
Hello.
I request Dr. Devraj Sarkar to present the concluding remarks.
Yeah. Sure. You give Devraj.
Hello.
Hello, Devraj. Yes.
Yes, sir. Am I audible, sir?
Yeah. Highly. I can hear you.
Thank you so much, sir. I feel privileged to have the honor of presenting the concluding remarks for today's session. On behalf of the Department of Electrical and Electronics Engineering, JC Belagavi, I express my deepest gratitude to Dr. Chandan Kumar Chanda, Senior Professor in the Department of Electrical Engineering at Indian Institute of Engineering Science and Technology, Shibpur, for sharing his knowledge on basics of solar forecasting. I would like to thank Dr. Chanda specifically for throwing light on the method of forecasting solar energy. His wisdom definitely enriched our boundaries of knowledge on issues related to penetration of solar energy. I would like to thank our beloved HOD, Dr. G.H. Kulkarn sir, for all his coordination and also the committee members. I would like to thank the teaching and non-teaching staffs for this FDP. And lastly, I will end my talk by thanking the members who have joined for this wonderful session. Thank you so much.
We'll be continuing with the next session shortly. I request all participants to remain online.
I request all participants to kindly mute your audio and video system.
Now I request Professor Viresh Kumar G. Mathad to introduce our today's speaker, Dr. G.H. Kulkarn sir, Head of Department of Electrical and Electronics Engineering, Jain College of Engineering, Belagavi.
Good afternoon, one and all. I, Professor Viresh Kumar Mathad. It's my immense pleasure to introduce our today's speaker, Dr. G. Kulkarn. Sir has completed BE in Electrical in 1985 from Karnataka University, Dharwad. He has completed MTech in Power System Engineering in 1992 from University of Mysore. Completed his doctorate in ANN Application to Power System in 2007 from JNTU, Hyderabad. He has published more than 30 papers in international conference and more than 7 papers in national conference. He has published more than 10 journal papers. He has 33 years of teaching experience. He served as a special officer at VT Belagavi for 6 years. Sir has served in many domains as a member of BOE, BOS, chairman of BOE and BOS, etc. He is a member of Technical Advisory Committee, HESCOM. Under his guidance, 4 students are awarded PhD and 2 students are PhD. He has conducted many workshops. In his leadership, Indian College of Engineering, Electrical and Electronics Engineering Department has got a grant of 20 lakhs for PhD. Under his leadership, department has designed and developed basic electrical engineering laboratory modules. With this brief introduction, I welcome you, sir. Thank you.
Thank you, sir, for introducing our today's speaker. Now I request Dr. G.H. Kulkarn sir to present the session on next generation electrical technologies and electric policies. Please, sir.
Okay, good afternoon, one and all. Namaskar. Just I'm making a small effort towards the electrical policies applicable to next generation technologies. The benefit of next generation energy technologies is hopefully throughout the interconnected network, that is generators, the transmitters, as well as the consumer end. Then only what we need is the support from the industry, the policymakers, and the public itself to reach the point of competitive maturity. The next generation technology have several challenges. The first one is how to use and deliver the energy. We already have the great improved efficiency. That is, you are not innovating any new generating technology. That is, once again, it remains the same. It's the basic principle of producing the electricity from the converting the one form of energy to another form of energy. We are not innovating any new fuels as such. But how best the available energy can be utilized with the better efficiency. That is a big challenge we have got. The next what we have got is they expand the mix of the energy sources in a way that are clean, reliable, as well as affordable, and at the same time it should be sustainable. That we have to look into. That is another challenge we are facing. That is, we have to use clean and reliable and affordable energy. At the same time, it should be sustainable. That is another challenge we have before us. The next one is how to create innovations in the energy technologies. That is how we have to better make use of the available energy. That is another challenge than with the regulations and the policies support. These are some of the challenges we are facing nowadays that we have to address these issues so that consumers will get a clean, reliable, and affordable electricity. That is, I am recalling one of the words from say that is in this particular field, just I am making a small effort towards making the things what is happening in the world with all the possible statistics and what are the other options, what are the solutions for these questions. We'll start with the next generation technologies and the electricity policies. That is the first mantra of an electrical engineer or the electrical technology. The consumer preference is the main motto for us. That is the main motto of an electrical engineer is to give a quality electricity, give the reliable electricity, at the same time you have to supply with the minimum cost. These are the three things you have to remember at each and every step of our electrical analysis, that these three things should be incorporated. That is the quality, reliability, and the cost. You have to give the quality of the electricity. It is nothing but the proper voltage, frequency, and free from the harmonics, that you have to give to the consumers. At the same time, uninterrupted power supply you have to provide to the consumer with the minimum cost. But whatever the improvement we are doing in the technology or trying to supply the electricity with quality, reliability, as well as the minimum cost, the demand goes on from the consumer side. That is, he is demanding better and expect more from us. Therefore, you have to look into the quality, reliability, and the cost. Then you have to proceed further. Then the balance of the trade. If you are applicable to the policies or the trading, that is, there is a balance between the supply and the demand. And whatever the new technology you are thinking of, then you have to make it. There is a demand is met with the proper supply. At the same time, it should be sustainable for the future generation also. That you have to make. That is what we are calling it the balance of the trade. You have to make this the supply point, the more the reliable, more affordable. At the same time, you have to make use of a newer energy mix so that at any given point of time, you have to meet the demand. Then the innovation is nothing but providing a better efficient the electricity to the consumers is with the help of the small the prototype the installation I am giving here. Then if you are looking into the power plant, the coal is capable of producing the electricity of 100 milliunits, but because of the losses in the power plant about 62%, then only the 38 units of the electrical energy is produced here, and it is fed to the transmission system. In turn, in the transmission system, you have got the transmission losses. Thereby, it is reaching to the consumer end. Then comes to the utilization for the electrical energy. In that case, if you look into that, the available energy is the 36 units. Out of that, the useful energy is only to, once again, the 34 units of heat goes into the waste or in the form of the heat. A small example. Then, what do you mean by that? The new energy technologies is applicable to each and every part of the system. Since from the generation to the transmission, even to the distribution, at the same time to the end users also. You have to look into the energy technologies, the new energy technologies in all the field. Means that is why I told you the initial remark that this next generation technology is applicable to each and every part of the power system. Then, how exactly you have to apply the new energy technology? That is the first thing is that then you have to improve the efficiency of the power plant itself. See, if you look into the 100 units of capable of energy, then out of this, only the output, what you are getting is the 38. That is what a loss of around 62 units. Then how to improve this? That you have to look into, that you have to provide the newer technology. At the same time, there is a transmission losses and other things, theft and other things. They are taken care for the metering, proper metering and other things. These are the new one by one new technology you are adopting the different system. At the same time, in the distribution level, you have to go for an automated distribution system so that you have to get the reliable electricity and it should be accountable. At the same time, the important thing is another one is the end user. Then you have to make use of most efficient the appliances so that for a lesser energy you have to make use of or whatever the applications you are using, you have to make use of a lesser energy. That is, how best, more efficiently you are using the electricity is another important fact. Therefore, from each and every part of the network, you have to apply these electrical technologies. Then, if you are looking to I am talking about the power plant, the efficiency. The power plant efficiency, that is, you have got a loss of 62. If you are taking a recent data from the General Electric company that they have published recently, that is, if you are going for a coal power plant, still you have got an average power plant all over the world. If you have put together, it is a 34%. It is a near 34% is the efficiency of the power plant. Then, if you are improving this efficiency to the 38%, they are projected 38% increase in the efficiency, the coal by the new next generation technologies. Thereby, it is you are reducing the 11% of the CO2 which is produced because of the coal power plant worldwide. If you look into the India figure, we have got a 27% of average power plant efficiency. Then we are targeting for 31% improvement of the energy by newer technologies, and thereby you are trying to reduce the CO2 emissions by 12%. At the same time, if you are looking to the gas power plant, you have got 39% is the project efficiency of the power plant, and in India you have a better efficiency of 45%. Then you have a targeting of 48%. Because of that, you are contributing 6% less the CO2 to the atmosphere. This is how there's a lot of the scope is there. You have to apply our new technology so that the resources are available. Then you have to extract more from that. That is the next generation technologies. Then defining the new generation technology definition, that is an essential feature of most renewable sources. We know that it is a intermittency. That is, it is not producing a constant power supply and it is not so reliable. Because of that, you have got a different problems. One is the efficient mixing of these sources, that is renewable sources, with other reliable sources such as nuclear, thermal, as well as the large hydro power projects. Then another, the problem you are getting, the mixing up of this renewable energy is that the market mechanism. That is, because of not the fluctuating the generation, it is all depending upon the environmental effect, then there is a problem with, there is a mixing up of the renewable energy is the one main problem. The another one is how exactly the market is expecting from the renewable energy, then what benefit you are getting, that is another problem. Therefore, what we have to do is, it is essential that the next energy technologies effectively address and resolve the societal difficulties associated with the current energy mix worldwide. What is the combination of the different energy they are using? Then you are addressed properly. That is our motto of the next generation energy technology. At the same time, these technology must also support most efficient emerging principles of environmental law, that is called as sustainable development. It is sustainable development means you have to provide the electricity with keeping the mind in the future generation. That is, there is a definition from the World Commission of Environment for the sustainable development. They are defining development that meets need of the present without compromising the ability of the future generation to meet their own needs. So, to keep it something for the future that you have to look into. Then the sustainable development is supported by use of adaptation of only the renewable energy sources. That is, sustainable development is possible only with the help of the renewable energy sources, with the expectation that large scale hydroelectricity. They are the nowadays the large scale electricity, the hydroelectricity is taken out from the renewable energy source because they are making some deforestation and other environmental aspects. Therefore, the sustainable development is very, very necessary. At the same time, you have to mix up the renewable energy sources. What are those the indicators which decides this sustainable energy development? That we will see one by one. That is, one is the sustainable energy development is necessary. That is, mixing of renewable energy as be universally accessible. These sources of these technologies should be universally accessible. At the same time, it should be affordable, and also it has to satisfy the health and safety requirement. It has to satisfy and assures the efficiency of the energy conversion and distribution. You are seeing that it is a very less the efficiency. Still, if you are going for solar and other things, the efficiency is very, very clear. It is in terms of 20 or 24%. Therefore, assure the efficiency of energy conversion and the distribution. And promote energy efficiency in all sectors of the economy. The economy is dependent on not only the usage of the field for our electricity, some other purpose of vehicles, transportation, and other things. The maintain diversification of energy supplies. That is the what you are calling is the liberalization of the generation, the transmission, as well as the distribution of the electrical energy. At the same time, the indicator of sustainable development is that maximize the energy security. At the same time, you have to see that the secure power system. And at the same time, preserve soil and water the quality. That is very, very important for the environment point of view. Avoid excessive the deforestation. These are the points to be considered when we are applying the sustainable development of renewable energy sources. And the only solution for sustainable energy development is the integrated energy network. What we are going for? Integrated energy network. The integrated energy network has got mainly three pillars and is depending upon. One is using affordable, cleaner energy through efficiency and electrification. That is the first pillar. The second one is the producing the cleaner energy. And the third one is the integrating the energy resources. These are the three pillars of integrated energy network. That is, you have to mix the different energy level so that you have to get the affordable, reliable, and the clean energy for the society. The goals what we are setting for our the electrical the policy is it is wholly based on this integrated energy network. That is, the first one is using affordable cleaner energy through the efficiency and electrification. That is, it is only possible when if we are mixing the source by the solar, wind, and other renewable energy sources so that they are very clean. And at the same time, you have to see that their efficiency should be the more. Then you have to producing the cleaner energy. Then you have to look into for the availability of the energy sources so that you can properly mix it up. Then the third one is integrating the energy resources. Here, this point integrating the energy sources is not only for the producing the electricity for some other purposes. They are also the emitting the CO2 from the atmosphere. Therefore, to integrate the energy, what we need is that use affordable, cleaner energy through efficiency and the electrification. At the same time, producing the cleaner energy is another big task. Then how you have to make use of the different technologies and which are the renewable sources. Nowadays, we are going for the tidal also. There are some of the then sea level. There is a generation. The different options you have to explore so that you have to produce the cleaner energy. At the same time, you have to integrate. This is the task of the integrated energy network. Then this integrated energy network won't happen automatically. It has got certain steps. That is, one is to manage energy and natural resources as an integrated system. That is, the managing the things. That is, what are the different resources are available, how best can be integrated, and it can be used. And the second, the point that is by applying the integrated energy network, guide an efficient transition to much more digital, dynamic, and network energy system. For this integrating or managing the things, what you need is the different digital and dynamic networks in the form of a communication. That also be provided. Then the next one is accelerate the development of cleaner energy. That is, you have to invest more and more in the renewable energy and you have to accelerate the development process in the producing the cleaner energy. Then unleash the promote the opportunity for efficient electrification. That is very, very important. That is how best the generated electricity should be transmitted and distributed and how best it is taken by the end user. That also you have to look into. Then only it is possible to reduce the pollutant to the atmosphere by the renewable energy sources. Then create a new business models giving a lot of the benefits and the regulations you have to make accordingly so that the more and more the people they are come up with the newer technology, renewable sources, they are come forward to generate the renewable energy sources. Then the last one is the increase the energy system resiliency and security by protecting the privacy. That is, there are people they come for the investing in the renewable energy sources. Then you have to make the model in such that resiliency. That is, how fast you can recover whatever you have invested on renewable energy. These are the things you have to look into when you are integrating the energy network. Therefore, you have to give a sufficient the policy matters so that the more and more people they will come up with the newer renewable sources. They are involved in the producing the renewable energy sources. Then, with the energy mix, if you have looked into the worldwide how exactly the energy mix is taking place, that we have to see. It is this worldwide electricity generation by the source. If we are looking into the generation, still it is dominated by the fossil fuel. That is, the most of the electricity is generated by the fossil fuel. Then comes the hydroelectrical energy, then the nuclear, then the other renewable energy sources. That is one of the MIT eminent the professor, that is Robert Armstrong, they stated in one of his statement that is still 2050 will still getting the 75% of our energy from the fossil fuel. But our next generation energy technology, what is our objective is to bring down this curve to the down so that the green curve, that is the renewable energy sources, produce more and more so that you can make the sustainable development of the energy. Then if you look into the usage of, that is the production of the electricity, if you are looking into the another chart, it is, if you look into here, that is 70, around 80% of the electricity is produced by non-renewable energy sources, only it is 23% or 24% is from the renewable energy sources. So that the sale of this renewable energy source, so that you can increase, so that you can keep something for our futures, because the non-renewable energy sources can be reduced. If you are looking to the annual electricity net generation in the world, that is, I told you, so most of the generation is from the fossil fuels. That is a dominant, that is what you are calling the base load, which is, it is supplied by the fossil fuel. Then comes the nuclear. Then the hope is that the graph is the study, that is the renewable energy sources. This is a hope for the next generation. The primary energy consumption by source worldwide. Then it is what we are seeing here is, that is the production of the electricity by the sources. Then the different sources, how they are taken up by the people in the world for all the sources, all the energy sources put together. That is, first if you are taking here the curve, the blue curve, what we are seeing, it is a oil. It is a oil is used as a primary energy consumption. It may be industry, it may be for a transport, it may be for the vehicles and other things. The next maximum energy there, what they are using is the coal, then comes the natural gas, then comes the renewable energy sources. They are using the lesser and lesser energy. That is, what our objective is to reduce the usage of oil and the coal. That is, the Professor Chanda is writing, pointed out, there are life of the different sources. That is another 75 or 50 years. That is the availability of this coal and the oil goes on declining. In that case, you have to find out the different solution. Now only you have to wake up and you have to think for the renewable energy sources, so that you can make use of the renewable maximum extent, so that the burden on coal and the oil should be reduced. This energy consumption by source worldwide, that is in the form of another graph. Once again, it is oil is the major, the component they are using as an energy source. Then the coal, gas, and the smaller portion is the renewable energy sources here. Then the electricity share of the total energy consumption by a sector, and how the electricity is used by different consumers worldwide. If you are looking into an interesting graph here, that is, apart from the industrial or commercial, the load itself is the greater. It goes on increasing. At the same time, the residential is also increasing. At the same time, the declination of there is an industrial aspect, and the transportation is still a flatter. Then what you have to encourage here is you have to increase this transportation load combination, so that the burden on oil can be reduced. So this is how it is put in the another graph, that is out of the total energy, that is, it is a worldwide, what it is showing is around 42% they are going for the industries and other commercial purposes, and the 27% is the residential. He is putting the 22% as the commercial and public services. For other purposes, we have got a different combination of 4, 3, and 2%. This is how the net generation from the renewable energy sources in the world is growing. That is, once again, if you are observing this particular graph, then the base component of this renewable energy sources, it is treated as a hydroelectric power. But nowadays, this hydroelectric power plant is removed from the renewable sources. That is the large hydroelectric. The small hydroelectric still is with the renewable energy sources, but a large hydroelectric power plant are not a part of a renewable energy. But if you are looking at the graph, it is taking into consideration the hydroelectric power, but most of the component which is contributing to renewable energy sources is hydroelectric power. Whereas the other components, that is geothermal, wind, and the solar, have got a smaller percentage. But there is an increase in the generation of the renewable energy sources. That is a positive side what we are getting. This is how electricity production in India what we are saying. We are looking into the Indian perspective. We have got a very encouraging thing is that once again it is the maximum production of electricity is through the coal. That is, if we are looking into this, the coal is the main source of energy in the India also. Then comes the natural gas, then a small portion of the nuclear, then oil, then the renewable also is very encouraging. The renewable energy source of production in the India is very encouraging. Then this is how there is a increase in the production of the renewable energy sources over the years from 2009 to 2018. If you are looking into the present report of the CEA, Central Electricity Authority, excluding the large hydraulic project, the contribution of renewable energy for 23.9%. The total, whatever the 100% energy if you are production, if you are taking, out of that, around 24% is contributed by the renewable energy sources. Then this input installed capacity around 9.8% from the solar, around 10.1% from the wind, and biopower is around 2.7%, and small hydro projects they are contributing 1.3%. That is around 24% of the total energy generated in India. It is contributed from the renewable sources. That is very good sign for us. Then one of the last year, the PM Modi announced that we are targeting around 175 gigawatt of production of generation of electricity. Also, is committed around 450 gigawatt by 2022. It is that step there is a possible increase in the production of renewable energy sources. What we are finding. Then, if you are taking overview of the India's energy system by fuel and the sector, that is, this energy is for the total energy consumed by the different sectors, including the industry, transportation, and the energy. If you look into the TIP, that is the total energy supply. The total energy which is supplied is called as a TPES, that is a total primary energy supply. This is a total energy supply by different the sources here. Out of that, what you are seeing is TFC, that is what you are calling is total final consumption. That is supplied is this much. There is a gap of this. It is because of transport and losses. There is a lot of losses in the utilization of the conversion or utilization. There is a loss here. That you have to bridge the gap by the next generation, the technology, so that the most of the whatever the available energy can be utilized. The most of the available energy can be utilized. These are the different sectors what they are using the energy is. One is the major is the industries, residential, transport, and other services. They are using the total energy. It is for all the purposes. Indian energy system is largely based on use of coal for power generation, oil for the transportation and industries, and biomass for the residential heating and the cooking. These are the different energy sources that are mainly used for make use of. Then, if you are taking the installed capacity of the India as a whole, then if you are looking into this figure, I told you it is around 24% of the generation is by the renewable energy sources. Then there is a large of the increase in the share of renewable energy by this 2020 from the last results. That is the share of the renewable energy in India overall installed power capacity mix rose marginally from 36.2% at the end of the first quarter year of 2020 to 35.9% at the end of the calendar year of 2019. In the first quarter itself, there is a large increase in the renewable energy sources mix. It is from the last year end, we have 35.9% of share of renewable energy. Now, at the end of the March 2020, it is rose to 36.2%. Then, as on March 31st, we know that we have got around 3,12,020 is 31 2020 as on March 31 2020. The country total installed capacity is stood about 372 gigawatt, up from 354 0.6 gigawatt during the same time year in the last year. You can see the increase in the generation, that is 358 to 372 is the increase in the generation. It is mainly because of the contribution from the renewable energy sources. Then if you are taking the other important graph as far as the India is concerned, based on this only you have to study, you have to apply our renewable technology. The percentage of electrical consumption of various sectors, if you are observing keenly, after the independence, we have got most of the electrical energy is consumed by the industries. It is a lot of the electricity is used by the industry. Then drastically there is a drop in usage of electricity for the industry's purpose. Nowadays, now slowly it is picking up. At the same time, there is the use of the electricity for the agriculture is goes on the increasing. You can see the graph here. There is the demand for the agriculture is goes on increasing. At the same time, there is a commercial use of the electricity is also increasing. That is, this is how there is a pattern of the load that is on the system in India. If you look into the current scenario of India, we have got 372 gigawatt the total generation as on 31st March 2020. Then at the same time, the gap between the supply and demand gap, what we are looking here is it is minus 2.1% peak, and during the average period of load period, we have got only the gap between the supply and demand is minus 0.7%. Then during the lockdown, if you are observing some of the interesting statistics, the total demand goes down by 8%, and they have saved around 30% of the coal. They have saved the 30% of the coal because of the COVID-19. There is a drastic decrease in the demand by 8%. Now you don't have any the supply and demand gap during this particular period. And the per capita power consumption is another the figure of merit that we are looking for in the as far as the electrical engineering is concerned. It is 1081 kilowatt hour. That is the per capita power consumption. That is, it is available electricity per head in India. So that if you are comparing the other USA and Canada, they have around 7,000 kilowatt hour of electrical energy they are getting per head. That is, it is linked to our GDP, so that if you are increasing this per capita power consumption, and we have got a development nation that we are getting. Therefore, you have to give the more importance of per capita power consumption, that is 1081. It is only possible by the energy conservation and more efficient usage of more efficient appliances. Then we have a load power factor is around 65% and is quite well. Then electric coverage, that is as on today we have around 99.7%. The another 0.3% is lacking because it is not accessible to the network. You have got a sufficient electricity, but it is not accessible because of the hilly regions and other things. Nowadays, that is also taken up in the form of the distribution generation network currently. Then the gap is not much. If you are looking into the present CEA report, it is a very interesting. The two figures you have to observe carefully. The R&M is not repair and maintenance. It is renovation and modernization. It is a renovation and modernization is cost-effective method of making use of the better available energy. That is, if you look into the production of a new electricity by the hydro power plant or a coal power plant, you need around 1 crore for production of 1 megawatt of energy. And around 60 to 70 lakhs rupees is required for hydro power plant to produce 1 megawatt of energy. At the same time, if you are looking to the quick return options for increasing generation, new capacity at the rate of 4 to 5 crore per megawatt. That is, you have to read carefully here. To generate the electricity, new electricity, then what we need is around 4 to 5 crore rupees per megawatt to generate the electricity. If you are investing 1 crore in the thermal power plant will get 1 megawatt. But to produce 1 megawatt new, we need 4.5 crore. That is, you are saving around 3 crore rupees or 4 crore rupees in this only, in the thermal power plant. If you compare for modernization of hydropower plant, we need around 60 to 70 lakhs to produce 1 megawatt of energy. However, newly if you are producing the electricity from the hydro plant, it needs around 5 crore rupees. Therefore, if you, instead of going for a newer generation, what you have to do is you have to do the modernization. You have to do the modernization of the present system so that innovation and modernization, if you are investing the lesser amount, then you are getting a more return out of it. That is why they are observed there are 170 thermal power plant, they are need renovation and modernization. And it is capable of producing 11,000 megawatt of the electrical energy. At the same time, they are identified 3500 power plant, they are capable of producing 3,000 megawatt units identified from renovation and modernization by the Central Electricity Authority of India. Instead of going for a newer the generation with the lot of investment and the adverse effect on the environment, you have to improve the existing power plants so get the more and more energy. And at the same time, we have some goals in the form of the India is producing 6% more power in 2018 compared with the deficit of 6.2. In the 2017 and 18, if you are comparing, you have a deficit. In the 2008, you have a 6% more electricity we have produced, and the peak load is also it is decreased from the over year. That is, we have a surplus of around 2.6% against the deficit of 2.2%. At the same time, deficit is mainly because of the lack of the transmission constraints. Okay, not proper the connectivity. Because of that, we are seeing the deficit. We are getting a lot of the generation, the hydro power in the northeast, but we have got our load is concentrated in the south. Then there is no proper connectivity from the north to the south. Therefore, there is because of the lack of the transmission system, there is a deficit is existing. The actual shortage would depend on the extent to which the state is able to get additional power from the surplus states. This is how we are to, these are some of the hopes in the Indian electricity that you are seeing. These are some of the growths in the economy, that is the GDP is also increasing. At the same time, your electrical generation is also increasing. And at the same time, what was important is the energy related CO2 emission is goes on the decreasing. That is, with the GDP, we are increasing our generation. At the same time, the contributed the CO2 to the environment is reducing. That is a very good sign what we are seeing from this trends in the growth of the economy. Okay, this is how what I explained, and we will go to the next because we have to touch upon the energy policies. So some of the ills what I am listing out here from the power system as we are facing in the India, it is inadequate power generation capacity. Now it is almost it is solved. We have got a lot of generation, but how properly it is transmitted and distributed and it to use is the main problem now. Lack of optimum utilization of the existing generation capacity. How best we have to make use of this available energy. Then inefficient use of electricity by the end consumers. That is how best the consumers are utilizing the available energy. Then inadequate inter-regional transmission means I pointed out that there is a lack of a transmission system. The huge T&D losses have skewed tariff structure, making the state electricity boards unviable. These are some of the problems they are facing the electrical industry. Because of that, there is a gap is still persisting. Then drivers and innovators of energy sector. That is what you need is we are going for a newer technology. You are going as a nation or a developing country. Then there is a lot of demands from the different sector. That is we have got a growing population in the electricity. There is agriculture production is also increasing. For agricultural purposes, we need the electricity. Then there is a development in the industries. Also, there is a advancement in the technology. Then we are improving the quality of our life, and also we are going for purchasing. And there is the rapid growing of the SME also. These are the factors they are want the growth of energy sector. These are the drivers for the energy sector to grow. But at the same time, there is the problems with for developing the energy sectors. Then you have got a stringent regulatory framework. You have got then limited funds and the infrastructure that will improve. Then technological limitations you have got, and at the same time there is a international politics is also coming to picture in the form of nuclear fuel and disposal of nuclear fuel. These are they are setback in the energy growth in the energy sector. For that, the objective is to frame a proper electrical energy policies. These are the policy making body in the India. Let's start with the Prime Minister, and we have got an India Department of Atomic Energy. Apart from that, we have got a Ministry of Power, Ministry of New Generation Renewable Energy Sources, Ministry of Petroleum, Ministry of Coal. These are all they are making with a different body, that is Central Electricity Regulatory Authority, Central Electricity Authority, CEA, Bureau of Energy Efficiency. These are the people they are looking into the energy policy makers. Then we will define then what energy policy we want for a next generation and technology. Within 4 or 5 slides, I am looking for this energy policies. Is the scheme, that is the energy policy is the scheme in which the government or any organization addresses issues related to energy growth and usage, including energy production, distribution, and consumption. It is a scheme or a clear-cut guidelines from the government, so that how we have to produce the electricity, how best we have to distribute, and how we have to consume. These are the things that is directed by the government. That is what the energy policies. The energy policy is not only a different objective other than only satisfying the energy needs. What are the energy policies should have got a different objective? Not engaging freedom of action in international affairs as a nation or a community of the nations. That is, once the policy is set by the set of the countries or a country itself, that should be the obeyed by each and every one. That should be the objective. Whatever the policies are making for a group of a country or a world or for a particular country with a different states, that is abided by each and every one. And the second objective is reducing vulnerability to dependence and potentially devastating embargoes. That is, you should not go beyond the limitations. That is, you have to act according to what is stated in the rules and the regulations. That you have to abide by once the goals or the objective is fixed for the electrical energy process. Then the next objective of the electric policy is that avoiding intolerance spending for imports. That is, you have to make a policy in such a way that you have to make use of indiscriminately available resources, so that the burden on the economy should not be put on because of importing some of the oil and the coal and nuclear fuel and other things. That is you have to make a proper appropriate policy for that also. Making utmost use of national and regional resources. That is the same thing what I reiterated. That is, you have to make use of available national and regional resources. And that is another objective. Ensuring indispensable economic. At the same time, you have to look into the economic condition of that one. It is economically viable schemes that you have to produce the electricity. And at the same time, what monetary benefit you are getting out of it to the government as a society, and you have to make at the same time your most reliable, most economical, the clean energy should reach to the consumer end. These are the objective of the energy policies. With this objective, they have to frame the electric policy. Some of the importance of electric policies are it is helping in the economic development, also global attractiveness. That is, more and more people are attracting for investing in our country in the energy industries, ensuring the competitiveness in the global market. And also it helps progress and innovations in the energy technologies. Also, it is improving the socio-economic development of a society in large, because you are also contributing to the economy of the country. And it is helping the market regulations, that is opening up for the public participation, so that you get the reliable electricity with the cheaper cost, and the regulatory guidance for them, so that there should be guidance for them for how best you can distribute the electrical energy. And energy conservation and efficiency also they are restricting, that is you are making use of energy conservation and the efficiency, that is another advantage you are getting from the proper electrical policies. And controlling rapid energy demand growth, that is if you are going for any the rapid growth of the demand in the form of coming up over new industries with not a proper the permissions and the standards what is set by the government, that also you have to control properly. Increasing the security of the supply at the same time is very, very important. Your secure power supply should be the provider. That is the another importance of the electrical policy. Then promoting environmental sustainability and combating climatic changes also you keep in mind. These are some of the important points, that is the advantage what we are getting out of the proper electricity policy. Then the challenge before the framing the electrical policies are standard setting. What should be the standards you have to set it? That is, if you are mixing of the electrical energy, at what quantity you have to put it, what is the ETC impact on the environment, you have to put a certain boundaries that should be mentioned in the electrical policy. At the same time, how best you have to implement with the available resources, then what is the procedure for the implementation, that is going to define properly. And defining the regulation design is also another important. The nowadays, what the regulation design is involved is only the monitoring the cost per unit area and whether they are distributing the electrical energy or not, and other things. It is not only the things. You have to look into that. That is opening up of the market. Your regulation design market should be very, very neatly defined, so that more and more people they are involved. There should be a competitiveness among the different companies, and the different regulations tools what you have to make use for framing the electrical policies, that also look into. And the capture is the other the important the challenge while making the targets. That is, we are not only looking for the renewable energy sources to reduce the environmental impact, such as solar, wind, and other things. But at the same time, you have to include the nuclear power plant also. Also, you have to make use of the coal power plant with the carbon capture technology. Then, what should be the percentage of coal should be added to the total generation? How much capture you have to make use of? If you are making no capture, what is the adverse effect on the environment? All those things should be properly defined. That is another challenge you are facing in framing the policies. Then a lot of international coordination is required while framing the policies. Then the technological choices in uncertain times. That is because of there is a violation in the economics. In that case, what are the different technology, then how to compact with the energy production, distribution with the economics, that also we have to clearly define in the electric policies. The managing the political influence is the other big headache for framing the electric, because we know that there is at every instant of time there is the involvement of the politics they are involved for the betterment. Okay. Then the maintaining the consistency between the governance levels on a policy. That is, the policy level is there is a different structures in the country, that is from the central government to the state government to the different distribution companies, and there is a coordination among all these three. Then maintaining the consistency among the different levels of from the government level to state government to district, different distribution level, that is another challenge for framing the electric policy. The extending the individual and social acceptance, that is, even though if you are framing a good, better electric policy, whether how the people they are accepting this is the other headache for the policy makers. These are some of the challenges they are facing while framing the policies. Then the last one is they are looking for whether you want to go for liberalization or you want to keep it as it is controlled by the state government, central government, and the other things. These are the things what you have to consider while framing the sentence. Then ultimately our commitment of making the policies, the proper policies is very important. Is one is to reduce the CO2. That is achieved at least. You have to keep the target. You have to frame your policy such that certain target should be reached in a time frame manner. That is achieve at least around 20% of reduction in greenhouse gases. Then increase the energy efficiency to achieve the objective of saving 20% of energy consumption compared with the projections. That is, you have to find out the different technology so that you can save at least around 20% of energy. That is nothing but the 20% the energy generated. Then achieve a binding target of increasing the share of renewable energy over energy consumption. That is, whatever the energy consumption you are making, the consumption by the renewable should be the component of the energy consumption by renewable energy should be the increase. And at the same time, the proper energy services you have to provide to the consumers with a less price. That is most economically better electricity, better options of the electricity you have to provide to the electricity. That is the target commitment from the electric policies. Then some of the need for custom made, that is some of the conditions what you report, the custom made policies to sustain renewable energy that I am putting here on the slide. That is, you have to give the sufficient incentive or to invest in R&D to develop technology to reduce the level of polluting emissions and the atmosphere. And an incentive should be invested in R&D development for renewable energy sources. Incentive also be given to reduce the consumption of energy. If you are consuming a lesser energy, then you have to do some incentives. The competitively set pricing instruments, that is in the form of auction, there should be a competition so that the consumer get a better electricity with a lesser price. And you have to go for rent metering and billing and quotas and obligations. That should be enforced for the regulating body. That is, you have to purchase obligations, you have to put it, you have to from the renewable energy source, you have to purchase, you have to utilize that energy. At the same time, you have to set some of the renewable portfolio standards also. This is how there is a classification power sector policies. They are broadly classified. This timing is coming out, so we will find this side control. This regulatory and the pricing policies has got the two different total policies classified into regulatory and pricing policies. Another one is non-regulatory policies. In the regulatory and pricing policies, we have all stakeholders come into picture. At the same time, large-scale installation in the form of solar and wind, and the small distribution generation will also come into picture. And this and decentralized renewable for electricity access, that is also come into the picture. For all stakeholders, we have to look into the quotas and certification. That is, I told you, that is, they are making certain quota for producing and they have to certify. And in the large scale installation, some of the administrative and set pricing instruments is required, and competitively set the pricing you have to for the instruments, that is for the installation, they have to put some of the policies so that the rate should not be so high. And in the distribution generation, you have to give a little bit the encouragement for distribution generation, that is administratively set pricing instruments, the lesser price, and you have to consider your net metering so that in the case of the excess the power they are generating, they are fed into the network. And the decentralized renewable for electricity access, there should be legal pricing should be provided, pricing policy should be given, and grid arrival policies also it is provided in the case of regulatory and pricing policies. And in the non-regulatory policies, it is come under all projects are come into the different sizes are come into picture. Most of the things here it is the financial matter, financial and physical incentives for to produce the renewable energy come in the non-regulatory policies. That is for the investment purpose they are doing this. That is voluntary programs, the different programs they are putting into this one. Then, if you are looking into the policies which is implemented in this RPOs, that is what I am calling this. The RPO is renewable process obligations and renewable portfolio standards. These obligations are put on a state government. Therefore, how much they are achieved in the India that we are looking to, and incentives are invested in R&D to develop technology to reduce the level of polluting emissions in the atmosphere. It is a put for the RPO. Then only, that is in India, an assessment of state level RPOs found that the instrument has not been effective. That is, whatever the RPO we are putting, the renewable purchase obligations, renewable portfolio standards, whatever they are putting, they are put on the state government. In India, an assessment of state level RPOs found that the instrument has not been effective. Then it is in the 2016, out of there are 24 states they are agreed for the RPO, only the 6 states they are implemented the RPO partially. This failure is because of due to the lack of effective monitoring and enforcement of compliance. They are not making a proper compliance so that they have to follow the RPO, renewable purchase obligations and renewable portfolio standards. They have to put on the state government, they have to encourage the renewable energy sources, but only the 6 states they are complying with this RPO. Then what is our approach to make to achieve the goal for the electrical policies? In brief, I am saying here, this is the main objective, and to get the achieved outcome to be achieved at the least cost is that first you have to concentrate on decarbonization so that you are going to include more and more renewable energy sources. At the same time, security of the supply. These are the 3 outcome based. That is, outcome is the ultimately the policies on the next generation technologies addressing decarbonization and security of the supply. Then what is the strategies you are doing for this one? It is one strategy is to invest on the reliable energy. The another important thing is the smartness in the system. The smartness in the system is it a smart grid or a smart the interconnectivity should be provided so that you can save a lot of energy in this. Therefore, strategy is invest in smart and conventional distribution grid technology, or whether you are going for a conventional. Then for that you have to compare what are the benefits and the cost effectiveness. Comparing this, and you have to choose out of one model based on what target you want to achieve. Therefore, I am putting in a summary form that is a 4 building blocks of energy efficiency infrastructure based on the policy is. That is, the first one is the communication infrastructure, that is to allow bidirectional flow of information between the electricity suppliers and the consumers. And we need the innovative regulation and the rates, that is to provide the adequate incentives for energy efficiency, investment for electricity suppliers and consumers. These should be included in our regulations. And the third one is we need the innovative market in that to ensure that energy efficiency measures instituted by regulations become self-sustaining in the marketplace. That is innovative market we need, and ultimately to achieve this, what we need is smart and use devices. How best we can use our electricity, available electricity that are energy efficient and able to receive the responsive real-time signals. These are the 4 building blocks of energy efficiency infrastructure. If you are achieving this, definitely whatever the policy they are making, they are achieving. And these are some of the strategies. I don't want to go into in detail. There are different strategies. One is top-down smart grid investment strategy. It is most of the things they are investing on the smart grid and the communication part. In an implementer, only for smart grids, only for the distribution system. In the conventional system, that is whatever the conventional system of the controlling the power that adopting. These are the different strategy based on the available resources, the funding, then you have to go for the different strategy for the investment. And some of the good government initiative they are taken up for our electricity policy. That is recently, last month only, they are floated the draft electricity amendment bill 2020 floated by the Power Ministry. 6 amendments in 2003 from 2003 modernize or amended any bill on the electricity. Now they are taken up, they are floated on 2020. This 2020 draft electricity policy, they are provide measures to improve the regulatory discipline. They are implementing the regulatory system, that is a discipline, there is a accountability they are provided. Then private sector participation they are encouraging. Give a trust on the renewable energy sector, they are giving importance. And there are also clear policy framework regarding energy storage also they are doing for the electrical vehicles, and storage purchase obligations they are put into condition, and also ensuring the quality of the power supply also they are put in the 2020 amendment bill. Then automatic expected exemptions for allowed microgrids and renewable generation, backup power, energy storage, electric vehicles, they are encouraging in this particular draft policy. Then removal of minimum threshold on contract demand, especially for electric vehicle charging, that also they are removed from the 2020 draft amendment bill. Then recently, in the month of June itself, this month only, heard the Power Minister is announced a good design of real-time market, that is RTM. That is, the RTM is a organized market platform to enable the buyers and sellers pan India to meet their energy requirement closer to real-time operation. That is what we are doing here in this RTM is that is our options of the electrical energy is there. That is more competitive for the distribution company, so that can be passed on to the consumers also. Then ultimately, the other initiative they are taking is the PAC, that is a perform, achieve, and trade. That is, you have to perform well and you have to get the benefit out of it. Okay, that is what is taken. When compared to last year, that is in the 2010, for the energy efficiency or conservation of energy, then there is saving of energy around 6%. For 6% of the saving of the energy, they are giving some of the rebates or the incentives for those who are saving the energy. That is why it is called as perform, achieve, and the trade. And in 2018, that is saving of the energy because of this PAC is around 10%. So that you have to give the incentives those who are under the electrical energy, those they are using more efficient energy. Then ultimately, my concluding remarks are the policy-guided energy production and utilization. Socio-economic development has become the top priority in the policy-based regulation. That is, the policy should be guided energy production and the utilization. You have to produce properly, and you have to make use of a more efficient system, and you have to more effectively utilize the energy. That also we need. Then design the policy aimed to promoting low carbon technology. That is, you have to do more and more the promotion to the renewable energy sources. Design the policy to promote consuming less energy. That also you have to make it. So that how best the appliances you have the most efficient appliances you are using. New technologies, policies, and business models are essential to meeting the customers' energy and environmental needs. At the same time, it is benefiting to the customers as also at the same time. Then, what is the environmental needs that also to look into while finding the sellers policies. Address challenges of bilateral and multilateral market mechanism. That is, you have to give a lot of scope for liberalization in the market. That is for the transmission, especially the transmission as well as the distribution. Ultimately, the last word is energy policies decisions requires a knowledge of extent and accessibility of the energy resources. This is from my side. If you have got any some small questions, just can pose it, and I, best of my knowledge, I will see. Thank you.
Now the session is open for question and answer session. Any questions from the audience? Any questions from the participants? Yes, any questions from the participant side?
Now it is just to conclude.
Okay, sir. Thank you, sir, for addressing the societal difficulties. It was a very informative session, sir. Any feedback from participant side? Dolin, sir, any feedback from your end, sir? Yes, any feedback from participant side?
Hello.
Yes, sir.
Hello.
Yes, sir,
Can you hear me? Can you hear me?
Yes, sir. We can hear you, sir. We can hear you, sir. Continue, sir, please.
From KLS VDIT Halyan. The session which has been started from 10th onwards, they are very good. All the sessions, I attended all the sessions. The recent trends in solar forecasting, as well as the presentation from G.H. Kulkarn, sir, as well as the other people from IIT Dharwad, professors, are very good. I congratulate the team of the Department of Electrical and Electronics of Jain College of Engineering for conducting a 3-day FDP, which has helped the people, that is maybe the students or maybe researchers, in enriching their knowledge. I also congratulate the principal of your college for providing the opportunity for you to conduct such an event as such. Thank you. Hello? Hello?
Thank you, sir. Thank you very much, sir. Thank you, sir. Any other feedback from participants? The famous quote says, to the optimist, the glass is half full. To the pessimist, the glass is half empty. To the engineer, the glass is twice as big as it needs to be. So we engineers have undergone 3 days faculty development program by being optimistic, and we hope everyone have gained maximum out of the faculty development program. By this, we have come to the end of 3 days faculty development program on trends and challenges in next generation energy technologies. All the sessions were lively and wonderful. The sessions delivered by various speakers were very good and enriched with knowledge. To conclude here, I request Professor Vinodes Patil to deliver the concluding remarks.
A very good afternoon to one and all present here. I would like to begin with a quote: feeling gratitude and not expressing it is like wrapping a present and not giving it. It's my proud privilege to have been asked to thank the August gathering. On behalf of Department of E&D, GC Belgami, I express my deepest gratitude to Dr. Chaniraj Roychand, the founder and chairman of GGI Group. I also wish to express my gratitude to our principal and director, Dr. K.G. Vishwanath sir, for providing the support and platform. I thank all the plenary speakers. I am thankful to our HOD and speaker of the session, Dr. J. Kulkarn sir, for the way he explained the topics like supply and demand, generation, transmission and distribution was exemplary, sir. I acknowledge the stance support received from all the coordinators and the fellow faculty members. I thank all the non-teaching staff for their encouragement and support and involvement in successfully organizing this event. Finally, I am thankful to all the delegates who have turned up in a good number for their enthusiastic participation and kind cooperation in the event and making this event a grand success. Lastly, I thank one and all present here. Thank you. Uh, the link for the certificates will be opened soon through the WhatsApp group. Sir, any remarks, sir?
Okay. On behalf of our Department of Electrical Engineering and my personal behalf, I thank all the participants for actively participating in this 3-day FDP on next generation electrical technology trends and challenges. And you have to take a maximum benefit out of it. And if you have got any some of the research area, if you are finding out of these 3 days, then you are making some channelizing your queries towards the experts through our via media. That you can make use of. You are all basically the teachers who want to help each other. Then if you have got any queries regarding the research and other things, just you are guiding them towards some of the proper channels so that we can get the maximum benefit out of it. This is how you have to make the connectivity. The main objective of the FTP or joining the different conferences is that making the lot of the networking thing so that you have to know the different people who can learn the different things from the people, they have the different abilities. Okay, that you have to find it from such type of FD. And once again, wholeheartedly thank all the participants for participating in this. And I thank my own people, that is the team electrical engineering for arranging the wonderful this session because we are worried about the networking and the coordination in between and other things. That is Dr. Debra Sarkar, Professor Vinod Pandit, and the rest of our electrical engineering staff. Did a wonderful the job for conducting this particular event. I wholeheartedly congratulate and thank you our faculty members for arranging such a wonderful workshop. Once again, I thank one and all for participating in this particular effort. Over to Vinod. Vinod, sir.
Sir, attendance is already marked, and the e-certificate link will be provided soon in the WhatsApp link.
Okay, thank you one and all.
Thank you, sir.
Thank you, sir. Thank you.
Thank you, sir.
यार